Hi, I'm Jared from Lacework, and today we're going to take a look at some shared object files that Lacework Labs, the security research team at Lacework, found. Let's get started. If you're unfamiliar, a shared object file, or SO, is typically used to provide additional functionality to other executables via exports. Those coming from the Windows world can think of this like a DLL. If we take a look at the diagram, we can see that with normal execution flow, the binary headers are parsed, memory is allocated, and then in the case of dynamically linked executables, the legitimate shared objects or libraries are loaded and execution is continued. However, by leveraging the LD preload path environment variable, we can say, hey program, load libraries from this directory first, and then continue on with normal execution. This allows an adversary to have their program overload legitimate functionality provided by other shared objects and is commonly seen in both defense evasion as well as persistence mechanisms. For those coming from the Windows world, this is similar to DLL sideloading. So let's go ahead and take a look at the actual shared object now. I'm going to go ahead and run file on teammate.so, and right off the bat we see that it is not stripped. This is a huge advantage to us because the debugging symbols are going to be available to us to kind of get a little bit more context to what's going on. Now I'm going to go ahead and open this file in R2. After opening it in R2, I'm going to do a quick analysis, and then I'm going to see what functions are being exported. We have readdir and readdir64. Let's go ahead and reference the man page and see what exactly these functions do. Readdir, well, it reads a directory. If we wanted to hide from processes that typically are used to list contents of a directory or maybe even, running processes, this would be a good system call to override. Now let's go ahead and browse to these actual functions in Radar 2. Right off the bat, we see that there is a call to the original readdir. Again, having those symbols are really going to help us out here. I'm not trying to understand every little assembly instruction. I'm just trying to see a high-level overview of what's going on here. So we go ahead and we're going to scroll down a little bit. We see some string comparisons. We see some getting the process names. And then we see, whoa, process to filter. So that's interesting because right again, debugging symbols helping us out. We're going to have a specific process that we're looking to filter out when the readdir syscall is being made. So let's go ahead and take a look and see what this process to filter actually links to. So to do that, I'm going to go ahead and just search by the object of process to filter. And then let's go ahead and take a look again. And sure enough, it is referencing stir.teammate. So in Radar 2, abbreviations here, this means the teammate string itself. So if a process has the name teammate, it looks like this shared object will actually filter it out. Let's go ahead and experiment with that and see if we can get that functionality to be displayed. So let's go ahead and run a little program called teammate. In this case, it's just a hello world program that hangs after it prints hello world. Now we're going to go ahead and create a new pane, and I'm going to go ahead and do a quick process listing to show that we do in fact see teammate running as a process. But what's going to happen if we go ahead and re-execute this, but this time we use the LD preload environment variable to load teammate.so. Sure enough, we don't actually see teammate in the process listing, thus confirming our quick triage and reverse engineering efforts. Even when grepping for the teammate binary, we don't see it when we're doing the LD preload. Adversaries can leverage LD preload type of attacks in numerous different ways. Please be aware that this is just one quick example we wanted to share with the community. Thank you for watching. For more content like this, follow our blog and follow us on Twitter.